Hello everyone, my name is Sanjeev. In this video, I will demo how to create Flex Gateway custom policy using Policy Development Kit. I will also show you how to apply custom policy to a non-mule Spring Boot API. To develop the Flex Gateway custom policy using PDK, we need to set up our development environment. MuleSoft has given the step to install the software and tool and to set up the development environment. In this page under review PDK prerequisite. So here are the steps to set up our development environment. We need to install the Rust because we develop the custom policy using Rust. So this is the command to install the Rust. You can install this development environment either in Windows environment or you can use a Linux environment. So first you need to install the Rust. Then we need to install or update Rust WASI, that's WebAssembly system interface. So this command update the Rust and install the WebAssembly system interface. We also need to install the Cargo generate, and this is the command to install the Cargo generate. So if you are using Ubuntu, then you need to use a few more commands for installing some of the packages. And for Windows, you need to install the make. Here are the steps to install the make in your Windows. We also need to configure the Anypoint CLI. So first you need to install the Anypoint CLI. We need to use version 1.4 or later. In fact, 1.4.4 or later. Then we have to configure the credential information. So we have to provide authentication information. So this is a step to complete that. And at the end, you need to install the PDK plugin for Anypoint CLI. You may need Docker also. This is required if you want to debug your custom policy or you want to do some testing in your local environment, then Docker is needed, otherwise it's not needed. You can use Visual Studio for your writing the code for custom policy. So these are the steps. These are pretty simple steps to install the Rust and then WebAssembly system interface and Cargo generate and Anypoint CLI. I have gone through these steps and I have configured my development environment in AWS EC2 instance. But you can use your local laptop as well. But I have done here. Here is the public IP address of this EC2 instance. And here is the public DNS name for this EC2 instance. I have logged into this EC2 instance using PuTTY. I have configured my custom policy environment in this EC2 instance. Now I will create the custom policy project. So for that, I will copy this command. This command will create the custom policy project. Here we are using Anypoint CLI, PDK extension, and we are using policy project create option. This is the name of the custom policy I'm providing here. And here I'm providing the description of the custom policy project. So let me use this command to create the custom policy in my EC2 instance. Click enter. This has created the custom policy project in this directory. So let me see ls, and we have here query parameter forwarder project. Let me go there. So this is the project. We got the template project here. We have a Cargo.toml make file. We have definition folder, playground folder, source folder, target folder, and test folder. So we got the template project here. So let me pull this project in my Windows laptop. So I will go to the bin scp. I will refresh the directory and I will copy this folder in my laptop. So we got the query parameter forwarder folder here. So this is the folder. So let's observe the structure here. We have definition folder, we have playground, we have source, target, test, and cargo.toml. Let me open this. Cargo.toml contains the dependency. Whatever dependency we are using in the Rust code, we put the dependency here. So we add the dependency here. So it is like a POM file for our Java or Mule project. For Rust project, we have a cargo.toml. This is where we can define our dependencies. Now I will go to the definition folder. Here important file is gcl.yaml. Let me open this. Here we can see the title of the project and description. And here we define the properties. So these are the input parameter that we need to define for custom policy. And that we need to configure when we configure the policy in API manager, like when we configure the rate limiting policy, we provide the number of maximum request and time period and unit of time. All these input parameter we configure when we configure the rate limiting policy. Similarly, when we need to create a custom policy, we also need to configure the input parameter. So those input parameter we need to define here under gcl.yaml file, and under properties we need to define all those input parameter that we want to configure for the custom policy. So in this template we got only just one parameter, a string property, and type is a string, and you can assign the default value, and at the end you can tell what all the input parameters are required. Let me move to the another file. I will go to the source folder, generated. Here is the config.rs. Whatever parameter we defined here, based on that information, config.rs get updated during our build process. And here is the lib.rs file. In this file, we write the logic for custom policy. Here we use the Rust language. So here all the logic being written that we need to be applied for that custom policy. Here we have this config method and we have the request method. So any other logic you want to put, you can put under this, and you can create other function and you can invoke from here. So any package that we use in this file that need to have dependency created in cargo.toml. So any package that we use it for writing custom code, we need to create a dependency in this file cargo.toml, and we need to add the dependency here. These are the main files, cargo.toml for dependency declaration, gcl.yaml file where we define the parameters, we define the properties, input parameter that we need to configure in API manager. And when we run the build command, all those parameter get updated here in config.rs, and lib.rs then can use those parameter from the config.rs from here, and they can reference those parameters. And here we write the logic in the Rust for our custom policy. Now in this demo, I will use the example that is provided by MuleSoft. Let me go to the documentation. So here are the custom policy example that was provided by MuleSoft. I will use the query policy example in this demo, and we can clone the Git repository from here. So I have already cloned the Git repository and I got this example code here. Here is the custom policy for a query parameter. I will copy this code outside and copy it here, paste. Now I will update our template project that we just created, query parameter forwarder, from this example project. So let me explain what this example project does. For better explanation, let me go to the definition gcl.yaml. So here is the title, query parameter forwarder. It forward the query parameter, and here is the description. So what this custom policy does, it transfers the list of incoming query parameter into headers. That means whatever input parameter we are sending to the service or API where this policy is applied, what it does, it transforms the incoming query parameter into the headers. So it take out the query parameter from the URI, and before transforming, it preamble x minus query minus. So suppose if there is a query parameter A, then what it will do, it will take out the query parameter and it will create a header with the name x minus query minus A, and it will add to the header. And then it remove the query parameter and it creates a new query parameter named removed, and whatever the query parameter has been removed, that will become the value of this new query parameter removed. When we configure this custom policy, it asks for the query parameter that you want to transform to the header. That's why we are defining here one property query, and it takes the array. So this query parameter is of type array. So whenever we are configuring this policy in API manager to API, it will ask for the what all the query parameter you want to transform to the header. Now I will update our custom policy query parameter forwarder with the help of example. So I will go to the 4 files one by one. First I will go to the Cargo.toml. Here I will get the dependency. Let me open the Cargo.toml under this folder. So here we have a PDK, serialization, and the anyhow. So we don't need these four that we already have. So we are adding URL and enter tool. So here we are adding two dependency that we needed for Rust code. Let me save it. Now I will go to the definition folder, and here I will open the, let me first copy the value from query example definition, and from here I will copy the this property, query property. I will go to the definition, open the gcl.yaml. So here we already have one property, string property. We don't need this. I will replace this with the query property, and it is a required property. Let me change our description as well. I will copy this description and I will replace this one. Save it, close the file, save it. Now I will go to the source folder. This file we don't have to update. We will update using our build process. So this file will be updated automatically in our new project. So I don't have to copy anything from here. I will copy the lib.rs. So let me open first. So here you can see that we have first a config endpoint function. It is invoking the request filter and on request. Let me search the request filter. So request filter have the all the logic that we need to write in the Rust. And here we are calling the inner request filter function. So let me go to there. Here you can see that this filter takes the query parameter and forwards them as a header. So here we can see that it getting the state of the headers. Then it's reading the query parameter from header state. And here it manipulating the query parameter of the request. And here at the end, it forwarding desired query parameter to the header. So let me go to the update header. So here is update header function. Function takes the query parameter defined in the config and forward them as a header. So this is a logic. It's taking the query parameter and setting the header, and it's prefixing the x query dash name of the query parameter. Here is the modify query parameter function. So it is being invoked from the inner request filter that you can see here. So what it does, this function recreate the query parameter by removing the specified query parameter and adding new one that indicate that query parameter were removed. So whatever parameter we configure during our policy configuration for API, those parameter are removed and the new parameter is being added named removed, and we tell that in the value what all parameter has been removed. So this is a logic for that. Here you can see that parsing value for the removed new query parameter. We are appending the key for the value of the removed query parameter. So in this we are removing the query parameter that is specified during configuration, and we are adding new parameter called removed. So this is the code. I will copy this code and I will paste it in our custom policy project. I will go to the source. I will open this file. Control V, I will replace it. So in our new custom policy project, we took the help of example custom policy, and we updated the Cargo.toml for dependency. We updated the gcl.yaml for our query input parameter. And at the end, from the source folder, we have taken the Rust code from lib.rs and we replace the code in our query parameter forwarder custom policy project. This file will be updated automatically, so we have not changed this file. I will go to the query parameter forwarder. I will copy the updated cargo.toml. I need to go to the first project, query parameter forwarder. And now I will update the cargo.toml here. So replace this file. This file has been replaced. Now I will go to the definition and I will go to definition here. Now I will replace the gcl.yaml, replace it. Now I will go to the source directory, and now I will replace the lib.rs. Here I have updated the three files in query parameter forwarder project that is inside EC2 instance. I will go to the EC2 instance back. I will go to the putty. Now here I will run few make command. So first I will run the make build asset files. What it does, it generates the policy asset files that is required for building, publishing, and running. And it also does, it update the config.rs file source code from the gcl.yaml file. So if we have added the new input parameter or remove the parameter, it update the config.rs accordingly. So let me open the here config. I will open the config.rs here, and you can observe this. We haven't run this command so far, and that's why we do not have that input parameter here. Between this curly braces, there is no input parameter. Now I will run this command, and we should see source code corresponding to the this input query property input parameter. And right now you can see that nothing is there. You don't have any code for the query parameter. So let me exit here, and now I will run this command. Make build asset file. Let me go to the folder, and here I will run the command. Now if we will go to the config.rs file, here we can see that we have the code corresponding to the query parameter. It was not previously there. So this file has been updated because of the command make build asset files. Now I will run the build command. I will first need to go to the root of the project. Make build command compiles the WebAssembly binary of the policy, and that's what it is doing here. Make build command is compiling, and it will build the WebAssembly binary of the policy. Build is complete. Now we can publish this policy to the exchange. So let me run the command make publish, and we will go to the AnyPoint platform. Let me go to the design center. Sorry. Let me go to the exchange. Right now we don't have any policy. It's getting published. Sending to exchange. Waiting for publication to finish. Publishing completed. Let me go to the AnyPoint platform. Refresh. So we got the policy here. So policy has been published to the exchange. We can see that. Query parameter forwarder dev. Here we can update our documentation. Now I will use this policy, and I will apply this policy to a non-mule API, an API manager. So let me show you. I have an API here, Spring Boot API. It is running on 8092 on HTTP. And here I can invoke this API using my EC2 public domain name, and port I am giving 8092, and the name of the service is echo. So let me invoke it, and here we are getting the result. So it's echoing all the inputs. So whatever header we are sending, it is giving in the response. So this is a path slash echo because that's what we are giving here. Protocol is HTTP 1.1. Method get. Body, we are not sending any body because it's a get method. And here are the parameters. We are not sending any cookie. So for example, we add a few parameter here. A is equal to 100 and B is equal to 500. We should see that it's giving in the response the detail. We are sending two parameter, query parameter, A100 and B, sorry, we should say B is equal to 500, and we can see that we have two parameter A and B, 100 and 500 values. So it's a echo service. This is a Spring Boot service running on EC2 instance. Let me go to the my runtime manager and let me show you my Flex Gateway. I have deployed a Flex Gateway on my Ubuntu AC2 instance. So here my Spring Boot API is running. Also, I deployed the Flex Gateway on Ubuntu environment. So this is connected. Now I will add this Spring Boot API to this Flex Gateway. So I will go to the API manager. Add API, add new API. I will use the Flex Gateway and I will select this connected Flex Gateway. Click next. Let me click create new API. Here I will give the name Echo API, asset type HTTP API. Click next. Port 8081 because that's where my Flex Gateway is running. Click next. Route, I will say Echo API route. Here I will provide the upstream label Echo API. I will copy this URL and this is my upstream URL. Click next. So here is my Flex Gateway. Here is the API. This is the API implementation path. Save and deploy. API has been added to the Flex Gateway. Now I can invoke this API using Flex Gateway as well. I will give the port 8081 slash echo and we are able to see the response. So here we are accessing the API from the Flex Gateway and let me add few parameter, query parameter, and we can see that we're still getting the query parameter here. Now I will apply the custom policy on Flex Gateway on this API, Spring Boot API. I will go to the Anypoint platform. Here I will add the policy. Add policy and we should be able to see the option to add the custom policy that we just added. So this is a custom policy. We added query parameter forwarder, transform the list of incoming query parameter into headers with the X query preambles. So let me select this, click next. Now it asking the what all query parameter you want to forward as a header. So click add. So we can say param1, param2, param3. So we are saying if we are getting param1, param2, param3, we have to send as a header. Click apply. So this policy has been applied. Now if we invoke here and we will send the param1 100, param param param1 param2 is equal to 500, and we will say param4. Let me invoke this and let me see what happens. So we can see that we have a parameter here. It's called removed because parameter 1 and parameter 2 has been removed, and that's what it's telling because we specified during configuration here that if we are getting param1, param2 or param3, we should send as a header, and here we are sending param1 and param2, so it is transforming them as a header. So you can see that here param2 param1 param1 100, sorry, there is a mistake here, we should have and here, not at the rate, and now is better. Okay, param1 from this query parameter, it converted to the header x minus query minus param1 and has the value of the header. Similarly from param2, it's created a header x query param2 value 500, and we don't have param3 but we have param4. So it's saying that param4 value is nothing because we haven't provided any value. So it's saying there's no value. So we are sending param4 as it is. We are not converting, transforming to the header. We only transforming the param1, param2. And here we are saying actually that this param1, param2 has been removed. And for that we are passing new parameter, new query parameter removed. And this is the value of the removed parameter. Similarly, if we pass nothing for param2, still it will be removed. And here we are saying param4 is equal to 600. Let's try again. So here param1, we are passing the header with 100. Param2, we don't have any value. So we are passing with the empty string param2. And we also have param3 undefined. So we are also passing here param3 as undefined. And here we are saying we remove the param1, param2, and that information we are passing as a query parameter. And here we are not doing anything with the param4. Still it is as it is. So header will always have query param1, query param2, and query param3. If we are passing those value in query parameter, then we pass the value of the header here. If we are not passing any value for that query parameter, we are saying this header is undefined. Here we are telling what all query parameter has been removed, and that we are passing that information as another query parameter called remove. And we are not doing anything with the parameter that we are not configuring here in policy. This is all in this video. In this video, I showed you how to create custom policy project using Anypoint CLI PDK policy development kit, and you have to provide the your input query parameter. You have to provide the dependency in the Cargo.toml, and then you have to write your code in Rust, and you have to write the lib.rs for writing your policy logic in the Rust. Then you have to run the command make setup that download the dependency and create the file that is needed for build. And then we ran the command build asset files. It generates the policy asset files that is required for build, publish, run. It updates the config.rs source code for any parameter that we defined in gcl.yaml. Then we compile the WebAssembly binary file of the policy using make build command. And at the end, we publish the policy to the exchange. And we were able to see the policy here, query parameter forward tab. And at the end, I showed you how to apply the policy to the non-mule API. And we added the policy here in API manager, query parameter forwarder. This is all in this video. If you like this video, click the like button and subscribe the channel. Thanks for watching. Thank you very much.